Good morning, afternoon, or evening, depending on what time you're watching this episode of Constellation Crew, and welcome back to all of our regular viewers. So today, of course, last episode we did talk about how we were losing a Constellation Crew member, but don't worry, Kenya is on to bigger and better things. Of course, she is an amazing person, and I am so happy we got to get to know her with her time here. But we do have a super awesome special guest, if you haven't noticed. Michael, would you like to introduce yourself to the audience, please?
Absolutely. Hi, everyone. I'm Michael McConville. I am the president of the International Planetarium Society and currently the director of customer outreach for the Cosm Planetarium Company.
Okay, so what is IPS?
IPS is the world's largest organization representing planetariums. And so we represent planetariums in more than 50 countries around the world. We have more than 500 active members. And that gives us the opportunity to provide planetariums around the world with resources that they need to succeed, and also host conferences every other year. Our next one is actually next year, and it's going to be held in Jena and Berlin, Germany. But it's also a way for planetariums to network around the world and to help each other in education, in equity, diversity, and inclusion initiatives. There's a lot of work that's going into things like financial equity and compensation across the field, and really trying to find ways to be relevant for our domes around the world and to support the amazing educational work that so many domes around the globe are giving their audiences. It's such an important thing that we do here in the planetarium world. And IPS is an organization that allows us to support those efforts as much as we possibly can.
Wow, that's awesome. So if you're president, do you sign laws and stuff like United States president?
No decrees, no executive orders, but it's a lot about setting both the vision for IPS and how it is that we are going to represent planetariums. But it's also a matter of serving the community and doing everything that I can in my leadership role to make a better future for planetariums. This year, we're actually starting the centennial of the planetarium field. 100 years ago in October was the first star projector that was built in Germany by the Zeiss company. And we're beginning a 2-year-long celebration that encapsulates everything about our past 100 years of history and looking forward to how we stay strong and relevant for the next 100 years.
Wow, that's awesome. I've never heard of a 2-year celebration before, so this is actually kind of cool. The party really never ends until that 2-year mark.
No, October of 2023 marks the 100th anniversary of the planetarium projector, and May of 2025 marks the 100th anniversary of the first planetarium that opened at the Deutsches Museum in Munich, Germany.
It's all coming together. That's really awesome. I knew about the 100-year anniversary for the star projector, but I didn't know that last part. That's awesome. Okay, so it sounds like a really interesting career. I've never heard of it before. What got you to this point?
I've been an astronomy fan since I was probably 6 or 7 years old. Got first telescope at Christmas, took it outside, saw my first constellations and Mars and Jupiter and Saturn's rings through a telescope, and it has stuck with me. My academic background is not in astronomy. I have just long been an astronomy aficionado. My degrees are in history, and actually taught undergraduate history for about 5 or 6 years before coming to my current position. But almost from day one of college, been involved in planetariums, helped run a planetarium in Central Florida for almost 15 years. And it is something that is incredibly important to me. The education and the working with audiences and outreach events and the passion that people have for the universe. I like to say that space doesn't need us to make it cool. We just get a really cool job of being able to act as a connection between people and this incredibly amazing unfathomable universe. And that love of education and love of working with people and seeing their reactions and their understanding and them being inspired by this all is something that has made my career as a planetarian for the past 20 years so incredibly fulfilling.
Wow, that's awesome. That was really beautiful. I'm almost gonna cry now, but I won't, because we're not gonna cry on Constellation Crew. It's happy times. But it's actually very interesting. I always felt that if you were going to be involved in a specific field, you had to be educated in that field. But that's the unique thing about astronomy, scientific outreach, the planetarium field even as a whole, is that all different kinds of backgrounds come in with different educations, and they all have amazing things to contribute to the STEM astronomy field.
Certainly. And I think that I am a pretty common story in the planetarium world for all of our astrophysicists and our astronomers. There are theater majors and history majors and political scientists and engineers and the entire spectrum of backgrounds that I believe makes the planetarium world really unique and very representative of the people who are in our domes, that they can see themselves in who we are and how we sound to them and what we look like oftentimes, that we are much more representative of the people in our seats than we've ever been in the planetarium world. And that diversity of viewpoints and histories and perspective is really what makes what we do in science communication so much more effective. That it's not just this one type of person that's telling you a story and there's no dialogue. It's a conversation that we have with audiences every single day and help them better understand and appreciate the cosmos around us.
Exactly. That was awesome. Thank you, Michael. Before we move on to what we're going to be talking about on our episode of Constellation Crew today, I would like to ask Kyree if he has any intro questions, because we will do a Q&A at the end of the video, but does Kyree have any questions for Michael before we move on?
As far for intro questions, not any per se. I think a lot of these questions are probably better suited for the end of the show. So
okay, awesome. More time to ask. So today we're going to be talking about some constellations. Surprising to some, surprising, not surprising to others. But we're mainly going to focus on Orion, Taurus the Bull, Ursa Major, and Ursa Minor. You might recognize the last two as the Big Dipper and the Little Dipper. Let's remember that the Big Dipper is an asterism. So that is, but it is a part of Ursa Major, the constellation. So first come, first serve, we're going to talk about Orion, the hunter. And if you've been staring at the screen for a while, we are facing south, southeast, and I bet some of our viewers have already found Orion already. It is a very, very popular constellation, and in my opinion, pretty easy to see even in Muncie on campus, where there's a bunch of light, of street lights and all different kinds of things going on for light pollution. And if you haven't already, I'm going to show you where it is now. So here is south. And I'm going to go up because I'm attracted by this different colored star here. And that is in the constellation Orion. That is Betelgeuse or Betelgeuse. There's many different ways to say it, but a lot of people say Betelgeuse. So I'm going to say Betelgeuse today because that's what I know as well. So you have the two stars here where Orion's shoulders are. And if you go down, there's the famous belt of Orion. And then, of course, you have his feet or knees, depending on how you draw him. I'm going to zoom in just a little bit. Yeah, it's not as smooth as the dome. If you've been to the Charles W. Brown Planetarium, a lot of the moving around is a lot smoother, but I have a mouse, so. But Orion is unique and interesting, and one thing that I love to, when we talk about constellations we've talked about before, I love to try to see if there is something that I haven't talked about yet. Because if you think you know everything about space, just wait. Something new will pop up and you'll learn something new. That's the best part about space, is that there's infinitely many things to learn. And one thing I did learn is that apparently Orion can be seen in both hemispheres. Not necessarily at the same time, I don't think. There might be that special window where you might be able to, but I am very much learning about northern and southern skies and constellations. There are some constellations that unless I go to the southern hemisphere, I'm never going to see them. But Orion is one where both hemispheres have a chance to see Orion, which is great.
Yeah, Nicolette, the great thing there is that with the exception of the South Pole, which does have some people living there, almost every single person living today can see Orion in its entirety from where they live, except for the 12, 15 people that live at the South Pole, where they're only going to see the bottom half as the celestial equator goes directly through the belt. So the North Pole gets the top half, South Pole gets the bottom half, and everybody in between, we get to see the majority of Orion, or at least the part that is important for us, Betelgeuse and the belt and otherwise.
That is so awesome. And
that's really cool.
And that is something new for me, again, because I always thought that circumpolar constellations we've talked about before, and we will not get into today because that can be an interesting topic for some. But yeah, I thought that Orion was Northern Hemisphere, our special hunter. No, everyone can see the majestic Orion the Hunter as they should. Thank you. And back to Betelgeuse really quick. Betelgeuse is special. A lot of stuff has gone on with it. I believe it's a variable star. I know that it pulsates and changes in brightness. So pulsate, for our viewers, when something pulses, it has this kind of like whoa, whoa effect, right? If I say that sound effect, I'm pretty sure our viewers know what I'm talking about. So it'll get bright for a second, and then it'll dim again. And a second is, I guess, not the best description because these stars can pulsate over all different times. But we're not going to specify what timeline for Betelgeuse is. But I do remember Betelgeuse was in the news a while back about how it dimmed really suddenly and significantly. And astronomers were like, what's going on? So that was really fun. I don't know if Kyree or Michael remembers that or have any details.
No.
When you have a star that is as prominent and easy to find as Betelgeuse, and for our viewers, the magnitude scale tells us how bright a star is, and usually the lower the number, the brighter it is. So for a star like Betelgeuse, which is usually like a magnitude 0 star, it dropped into the magnitude 1 range, which is a significant drop, especially for a star that bright. And there were some thoughts that maybe this would be the beginning of Betelgeuse going supernova, right, which if it did, would be one of the very coolest things we've ever seen. But alas, back pretty much to normal. It looks like scientists were thinking that it was like a soot cloud of carbon that may have passed in front of it, and because of how dense that dust was, blocked a lot of light from reaching us here on Earth. And so we saw Betelgeuse dim down.
That's crazy.
That's really interesting.
I'm pretty sure that someone said it, whether it was our planetarium director, Dana, or our planetarium social specialist, Melanie, or one of my professors said that basically the star burped and produced all of this dust or this big cloud in front of it and dimmed it exactly like you described. And I'm just like, interesting. I didn't know stars could burp. Good to know. But of course, there's more to Orion than just its amazing stars. In fact, I'm going to zoom in on the belt a little. And already you might see some interesting things pop up as I zoom in for our viewers. So again, we have Orion's shoulders, the belt, and then this sword here. So I don't know about you all, but here in Muncie, I can see 3 dots making the sword in Muncie. I don't know if I have extraordinary vision or I'm just very lucky and it's very dark. But there are 3 points of light that make up the belt. And I say points of light because one in particular, which is usually in the middle, right here, is actually not a star. It looks like a star, but if you go to a very, very, very dark place where there's no light around you for miles, I would say, at least that's my preference, you would start to see that it's a little fuzzy. So I'm going to zoom in. And I think if I click on it and zoom in, here we go. So an image is coming up. This star right here is not a part of that image. That is a stellarium effect. We change the sky just a little bit so it looks more realistic to what we would see here in Muncie, Indiana. So of course, we might have to make the stars just a little bit bigger so we can see them. But yeah, this star is not in this image. But I'll center it. Whoa. Do my Constellation Crew members know what this is?
I believe that this is a nebula.
Yes, it is a nebula. Do you know the name of the nebula, Kyree?
If you asked me a month ago, it would have been fresh in my brain because my mom kept asking me about Orion.
Really? Okay, so this is the Orion Nebula. So
us astronomers are not the most creative people in the world. Like, you know what you're going to get here.
Yeah, pretty much. We do have some very interesting names, and usually the names cannot be changed because astronomy is such an old science that some of these names, even though they may not make sense now, they made sense a long time ago, and now it's really hard to change them. But that's okay. We work around it. We adapt. But the Orion Nebula is a very fascinating nebula to me because we talk about nebulas a lot on Constellation Crew. This one is known as a place where stars are born because there's so much. This image is absolutely beautiful, but there are other images that really show how epic this nebula really is, how big it is, how much gas is there, how much dust is there. Here at the planetarium, we do have a visual where we kind of go through this really awesome rocket ride through it, and you see the stars forming. You might see a star with a black disk around it that might be a planet being formed. All of these visuals are based off of accurate scientific data. So we didn't actually take a spaceship and go flying through the Orion Nebula. It's all based on actual scientific observational data. But it's a really awesome visual, and I highly recommend if you come to the planetarium when we ask for questions or requests to definitely bring it up. It really is a beautiful thing to see. Any comments on the Orion Nebula before I zoom out?
It is important for us to think about these colors.
Okay.
When we look at the Orion Nebula through binoculars or a telescope, the colors that we see in the images, they're invisible to us. Our eyes just aren't sensitive to colors in the dark.
Mm-hmm.
And so even big telescopes, it's green and maybe the ever slightest hint of pink. But when we take images like this and we can see those colors, that pink color we see throughout the galaxy, and that's usually a sign of glowing hydrogen. And if you have glowing hydrogen, that's one of the most important ingredients for new stars to be born, which is what we see in the Orion Nebula. And when we see blue in those nebulas surrounding it, that's generally a nebula that's reflecting light rather than giving off light. So that's reflecting the blue light from the stars around it. But that pink glow, that's the surefire sign we've got hydrogen gas. There's a lot of dust in there, a couple of ingredients and some gravity. And now you get sort of the stellar nursery that the Orion Nebula is.
Oh, there's the word. Thank you, Michael. I was trying to come up with a great way to say that specifically, but a lot of ones were popping up in my mind. I'm like, that doesn't work. That doesn't work.
It's where the baby stars
Fire them out.
Baby stars. Baby stars. Oh, really quick. I totally forgot. So this is actually a Messier object. I say Messier because I'm pretty sure that's how it's commonly said. Someone can please correct me if I'm wrong, because it is a French last name. And I say French last name because this was cataloged by a man named Charles Messier. This is a very interesting story, and I heard it here at the planetarium first. Charles Messier was trying to study comets of all things, which is also something we're going to talk about today. And he kept seeing stuff like the Orion Nebula and other objects we're going to talk about today, and he was getting very annoyed and frustrated because he thought they were a comet. They were not behaving like comets, so he cataloged them because they weren't what he wanted to study. Okay, that's just very mind-boggling to me because this is absolutely beautiful. However, comets are pretty awesome and majestic themselves, so I totally understand. If you're looking for something in specific and you're seeing everything but that, I would be frustrated as well.
And like the great irony that almost all of the comets that he did actually discover have been forgotten to history. And this Messier list is like the pinnacle of amateur astronomy. If you've got binoculars or telescope, there's 110 currently in the list.
Yes.
And you get objects like Messier 42, and
Yep.
that's and that and his telescope was absolutely terrible. So everything was a dim smudge.
Yeah.
But now it's like, hey, you come to the planetarium, take out a telescope, and you look at the Orion Nebula through that today, and it's stars and wisps of the cloud, and it's absolutely stunning. We have it a lot better than Messier did back in the 18th century.
Yeah. Well, thank you for saying the Messier object name for Orion, because it is M42 for our viewers, like Michael said. But we've seen Orion enough and the Orion Nebula. We are going to move on to another constellation, and I believe Kyree can help us with that as I painfully zoom out.
Yeah. Actually, you really didn't need to zoom out too much, because the next constellation that we are going to is Canis Major.
Ooh.
And how our astronomers at home can easily find it is actually by going to the constellation we just talked about, Orion. If we look at its belt, we can kind of draw a line through it, like a straight line that hits all three. And if we keep on extending it, you can kind of hit the brightest star in our sky, which would be Sirius. And Sirius is a part of the Canis Major constellation. Now, Canis Major, known as the Big Dog, is honestly the epitome of man's best friend, as Canis Major follows his, I'll say, mystical companion throughout the night sky. Honestly, I just want a husky that could follow me to the ends of Earth like that. That'd be great.
Yep.
But yeah, really not too much to report about Canis Major itself, but there is still a lot of interesting things within its constellation region. Like I said, Sirius is the brightest star in the sky, and it is in Canis. So if you did think that the brightest star was Polaris, our North Star, unfortunately, you are a bit misinformed. But it's okay. We all are learning new things every day, as I struggle to remember the Orion Nebula today.
I was shocked and amazed, but you know what? Being an undergrad is hard.
And then, as we were talking about earlier, the Messier, I'm going to call it objects. It's not called objects at all, and I'm probably going to hate myself. We actually have M42 inside of Canis Major, which is a star cluster. So it's also really cool to think about just how many there are. As we said earlier, there's 110, and having two objects sort of near each other in our viewpoint is great.
Okay. Did you say M41, Kyree?
Did I say M40? M41.
Okay, that's what I thought.
Yep.
All right. I don't know. I see a smudge here. I don't know if that's the smudge. That looks like a nebula to me.
Yeah, that's...
There's a cluster over here, though.
Should be a little further south of Sirius.
Okay.
We'll use the dog itself. I think probably near the right shoulder.
Okay.
Oh, nice dissolve.
Yeah. So, what are you? That's a planetary nebula?
Yeah.
Well, I could search it up for our viewers here, but to save time, I feel that, and to have me stop moving around, I think we can just move on from that, or maybe a magical star cluster will pop up on the screen for you all. Who knows? We shall see. But that I love. So what kind of star cluster was it? Open or globular? Or just a star cluster?
This would be an open star cluster.
Okay. Yeah. Cool. We're going to talk more about those in a little bit here too. But wow. Canis Major. Canis Major actually is a popular constellation for another planetarium assistant here. His name is Caleb. He has been on the Constellation Crew many times before. Our regular viewers know who he is and knows his face and name. But he is a grad student now, so he is doing bigger and better things for the planetarium. And he talks about it all the time, about Sirius, and for our Harry Potter fans, Sirius is Sirius Black, and it's ironic that it's the dog star in the dog constellation, Canis Major, because Sirius turns into what? For my Harry Potter fans?
What does it turn into?
A dog.
There we go.
Well, in the movies and in the books, dog is rather debated, because if you see him in the movie, he's not necessarily like a husky, Or a golden retriever, he's kind of just like a wolf, maybe? A dog.
Canine-esque.
Canine, yes.
Yeah.
Close enough.
And I mean, it is now, we're in the middle of winter. We haven't been thinking about summer. We'd like summer to come.
Yes.
But we still got a few months to go.
Yeah.
But that's Sirius. That dog star is where we get the phrase "the dog days of summer," because back in the times of the pharaohs is when this kind of came about. The star Sirius would rise at the same time as the sun, right around the time when the Nile would flood, and that, of course, would irrigate the fields and allow the civilization to continue. And it also corresponded usually with the very hottest days of summer. And so the Egyptians believed that the starlight from Sirius and the starlight from the sun combined together to make things hotter. We know that's not true, of course, but we've had those dog days of summer ever since. And they did have a pretty good idea that, okay, this is the brightest star in the sky. It stands out. It is also one of our closest neighbors. The light from Sirius takes less than 10 years to reach us on Earth.
Wow.
So when we look at Sirius in the night sky tonight, for example, we're looking back at light that left in the very beginnings of 2013 rather than 2023. We get to look back in time a little bit.
That's really cool. We've talked about very distant objects on the show before. So actually that's because the sun, I believe, takes 8 minutes. The light from the sun takes 8 minutes to get here. So that's
8 minutes for the sun and probably right about 9.5 years for Sirius. Yeah. Huge difference, but
that's still really cool though. I made a joke yesterday. We were talking about errors or something with a professor and said, oh, that's about an error of 1,000 miles. And one of my graduate student friends, Sam, said, in astronomy, that's perfect error. That's beautiful. That is dead on accurate. And I'm like, I mean,
we've got a couple of, on a stellar scale, yeah, we've got a couple of billion miles to spare in most cases. You know, this is quick math for us. If we wanted to get to Sirius and we were using mileage, this is something like 55 trillion miles away. It's a lot of zeros.
Yeah, that's a long road trip. It's still hard for me to grasp that number.
Yeah, 9.5 light years feels a little bit better, a little bit easier for us to chew on.
Exactly. Is there anything else about Canis Major you'd like to talk about, Kyree?
Nothing much. But going back to the Patron stock, for a little bit of fun, my Patronus is an Irish wolfhound, actually. So.
Oh, I love that. I forgot what mine was. It was probably, I think it was a bunny, which is very ironic.
I had a Patronus that seemed to not match with me at all.
Oh.
It is the hedgehog, and I am the furthest thing from a small woodland rodent. But having read into it, it does make a little bit more sense now, but not as majestic as the wolfhound.
Or a cute little snow bunny. Not to brag about myself here. But awesome. I love Canis Major and its connection to Harry Potter fan base. It's always fun to talk about that. But we still have some other constellations to move on to. So again, we're going back to our buddy Orion. Orion is just our helpful tool in the night sky. I love Orion. And we're going to go back to the belt again, like Kyree showed us, except we're going to go in the exact opposite direction. We're going to draw a line and go this way. And you might start seeing some really cool things and wonder what the heck those things are. This star in particular, in this awesome V shape. And this is not a star. Can my crew members tell me what this is?
A big, bright object that's red.
I lost him
in a zodiac constellation.
I think it's Betelgeuse.
Betelgeuse has moved, apparently.
Just minds of their own. Okay, so a wandering star.
Mm-hmm.
That sounds like the planet Mars to me.
Yeah.
Yes.
That sounds really familiar to Mars.
Yes,
I still think it's Betelgeuse, but
you never know. There's a lot of orange objects in this general vicinity over here.
It was actually hilarious. I lost your mouse for a second, so I thought you were pointing at the star below it.
first time I was wrong. But yes, this is the planet Mars here, and Mars does not stay here. So don't feel bad if you start getting confused with this orangish star here and Mars here. Mars won't be here for ever and ever and ever, so you won't have to worry about getting those two confused for much longer. But I just wanted to make sure that we pointed out Mars so that we're not looking at the wrong constellation here. But do my crew members know what constellation this is?
I believe that is Taurus. I believe you're pointing out the horns.
Yes. Very good. This is Taurus the Bull.
Nice.
One thing that I love to point out is that constellations help us map out the sky. It helps a lot of people navigate. So sometimes sailors will use constellations to help navigate when they're in the middle of the ocean. And I always thought as a child that when you connected the dots, that was the end of the constellation. You connected the dots, the second you hit that last star, you're done. That is not true. Constellations have these little boundary borders, which I won't bring up today because every time I try to sew something new, something goes wrong. But I have done it in past Constellation Crew episodes, so feel free to check those out. But the boundaries are important because you can connect the dots here. There's the V shape here. And I really want to bring up the constellation sticks, but I guarantee you I'm going to do something wrong. Just trust me that the connections usually are with this V here and elsewhere in his little feet, I believe, too. But there's this interesting object over here that does not get connected. It's not a stick figure with the rest of the constellation. And I believe it is called the Seven Sisters or the Pleiades. So again, I'm going to zoom in. How about I click on it? And then zoom in. Look at that.
Look at that.
Wow. I'm going to get rid of the constellation background. There we go.
It really doesn't take much to impress us, does it?
No, not really.
This is absolutely beautiful. So the Pleiades has a lot of legend behind it, as well as Taurus the Bull. But the Pleiades is an open star cluster. It is also another Messier object. And what's interesting about being an open star cluster is that there's two types of star clusters. There's an open star cluster and a globular star cluster. So an open star cluster is loosely bound stars bound together by gravity, and it's usually between, what's the number? Like hundreds to thousands of stars? It's a smaller amount than a globular cluster, but it's still a significantly large amount of stars. And you'll notice that they're all blue. And the stars themselves are blue. That's great. But you also see these blue wisps. It kind of looks really spooky looking. And like Michael said earlier in the program, I believe that the stars are reflecting their light off of the gas and dust, and that is why there's blue clouds going around. So, but since it is an open star cluster, I learned something new about open star clusters. I said loosely bound by gravity because apparently it is loosely bound for a reason, and they can start to pull away from each other eventually. This is a very long process. This could take years, millions of years, or it may not happen at all. It might just be enough to keep them there, but it's loosely bound by gravity for a reason, and they are typically pretty spacious. But it's just a gorgeous image. I love looking at it. And we have a full dome image as well in the planetarium. But
Really nice.
lovely Pleiades in the sky has a lot of background in terms with the Greeks and Romans. Oh my gosh, okay. We're gonna zoom all the way. There we go. There we go. Back to that. So the Pleiades, like I said, is not connected stick figure wise with the constellation, but it is within the boundary of Taurus the Bull. So it is a part of Taurus the Bull constellation in terms of boundaries. And a lot of people call this the Little Dipper because we already have a Little Dipper, but it kind of does look like a Little Dipper. And this is an object that you can see with your naked eye. It does look very similar to this in Muncie, maybe 1 or 2 stars less if it's really bright outside in terms of outside lights. And the Greeks and Romans actually used this a lot to determine if a soldier had really good eyesight. They would use this as a part of their training to look at the Pleiades and ask them how many stars they counted and with the Pleiades. And if they got to a certain amount, that told them they had superior eyesight.
Yeah. So if you look at the Pleiades and you see 6 stars, that's okay. Like most people, 6 is the limit. 7, of course, is the name. And I believe that the verified record is 14 with just the naked eye. Now, that was somebody likely had incredible eyesight.
Yeah.
Without glasses, 0 stars in the Pleiades.
Same joke I've made.
I couldn't tell you where they are.
The entire sky is a star.
If you can get 6, I think you're okay.
No, I think the entire sky is just black and nothing.
Yeah, there you go.
Colors just converge.
And see, they talk about that, but for our new viewers, if I haven't said this before, I don't need these to see. It's purely for aesthetic. I love wearing glasses, and I think I look beautiful with glasses, so I wear them. These are actually blue filter to help me with some migraine issues that I have. So,
Kyree, if only we could be so.
I know. I would never forget this one story that my friend told me like back in freshman year, and it was one of her other friends that she asked her back in like her sophomore year of high school, and she just looked at her and she was like, "What is it like just being able to wake up and you can just see it?"
It's kind of nice. I love looking at my white ceiling and my beautiful posters, and yeah, it's great. To answer your question. If it makes you feel any better, I was that obnoxious child at the eye doctor asking, Doctor, can I have glasses yet? Am I blind? No, you're not blind. Do I need to stare closer at the TV? No. And yes, my mom had to fight me on that when I was a kid because I really wanted glasses. But now I can just have them. It's fine.
It does make working with telescopes a little bit easier when you don't have to have the glasses on.
Yeah, and I will recognize that I do have the privilege of taking offset glasses because I did not realize that at the amount of times that I've bonked my glasses on a lens for telescopes, just like, now, yeah. I experienced the struggles of wearing glasses.
Well-visioned soldiers, Kyree and I would not be, so.
It's happening again, guys.
Fortunate.
Here we go. There we go.
It was a sea monster. It's okay.
I'm pretty sure. I forgot which one that is. It's not Draco.
That's Cetus.
There we go. Okay.
That is our friendly sea monster in the fall and winter skies.
Kind of like Nessie. Nessie's friendly. Have you seen Phineas and Ferb? Of course Nessie's friendly. Anyway, back to
what is it? 104
space.
Days of Constellation Crew? Is that what we're gonna try to eventually
104 days of Constellation
Crew.
Just to end it. Oh dear. Okay.
Annual problem with our generation is finding constellations just the way to stand.
I'm watching Phineas and Ferb after this. That's guaranteed.
Bringing it all back.
It's canon.
Bringing it all back.
But back to space stuff. Before we move on to I believe the star of the show, pun intended, I wanted to point out this orange star again. This is Aldebaran, and it is orangish reddish in color, and you can see the difference again in a dark sky. But Aldebaran is fun because if I click on it again, coincidentally Aldebaran is in the drawing right on the bull's eye, which is very funny. It comes with a lot of fun jokes about, red-eyed bull, he's angry, and bulls hate red. All that fun stuff. But we do have another important object that I would like to discuss on Crew today, and we're starting to run out of time. So I'm going to pass the mic to Kyree again, and we are going to be talking about a comet, right?
Yes, that is correct.
A comet?
So the comet's name is, I believe, E3 ZTF. Funny names. Astronomy. I'm
going to start.
I believe the path should be in the north by Ursa Minor, Little Dipper asteroid.
So
I know stuff.
There we go. Zoom in just
so I will say that the best viewing days are when it's at its closest approach, which would be today and tomorrow in the pre-dawn hours.
Okay.
Yep. But let's step back before we talk about all this viewing and all the pathing and all that, fun technical stuff. And let's actually just break it down to what is a comet and what is a meteor.
So that's a great question and can be very hard to describe because if I were to describe it the way I'm thinking. I feel like it's misleading, but I'm going to give it a shot. So meteor showers do originate from constellations, and because, you know, so like there's the Geminid meteor shower, because the meteors appear to come out of the Gemini constellation. And now what's the origin point of the meteors, right? Why are these tiny little things coming out of these constellations? And I believe it has to do with either a meteor or a comet. This is great that we're discussing this. An object, a rocky object, comes very close to Earth, but it starts to heat up and break apart and create that meteor shower, if I remember
we're
correctly.
usually having the Earth go through sort of these debris fields, and some of it could be from comet passes. There are a couple, the Geminid's one of them, where it is an asteroid with a debris tail. And as we move around in our orbit, those debris trails tend to stay in their own orbits. It's basic, basic orbital physics, and it allows us to predict them with regularity and precision. And so maybe when we're passing through the tail or the remnants of Comet Halley, that tends to be right around the middle of October. And the point in which they seem to originate from is inside of Orion. So that's the Orionid meteor shower in October. And because we have some consistency in our movement, one of the great things, we then have consistency in those showers. So the Geminids or the Perseids or the Orionids or the Leonids, all originating from what looks to be the constellation. They're, of course, much closer to us than the stars might be, but often debris clouds of very, very small materials. And then, of course, when they run into the Earth and come through the atmosphere, they very rarely will make it to the surface, but they will be seen sort of burning in the atmosphere. And we see that meteor glow as it's moving at this incredible rate of speed. Some of them are big, some of them are incredibly bright. And then, of course, there are the dimmer ones. But those debris fields that we go through give us our consistent sort of year-to-year meteor showers.
Okay.
And the difference between a meteor shower and a comet is that the comet is actually just like a chunk of ice, rock, dust, and essentially it originates from something called the Oort cloud. Now, for everybody who doesn't know, you could say the Oort cloud is like the large cloud of comets at like the outer edge of the solar system, like far beyond Pluto. But the problem is, it's like it's only observed. So I made this joke once when somebody told me about it, and it's like we're in like a comet blanket, you know?
There you go.
And it's a big comet blanket, and it's important to. I'm glad like you brought up, like it is an astronomical theory. Comets that are this far from the sun, we're talking like halfway to the nearest star in some cases. That's 2 light years. They're incredibly dim and would be impossible for us to see with our modern telescopes. But the way that we see comets coming in from the outer solar system, the way that we've seen other aspects of the solar system and how we try to explain those in the most scientifically appropriate way, that leads us to believe that, there's trillions of these comets that surround the solar system. And one of the thoughts is that, if a big comet makes its way into the inner solar system, maybe hits the Earth, think back to like the time of the end of the dinosaurs, that it could be that as we move through the Milky Way, we get closer and further away from stars, and their gravity is actually messing up the Oort cloud and sending some out of the solar system completely, and some of them hurtling in towards the inner solar system. And from our observations, it seems to fit with this idea that we have this trillion of comet cloud surrounding us in all directions.
Wow.
Yep.
Yeah.
But we must go on. And the reason why when a comet comes in, essentially the heat evaporates the gases that are within the comet and like creates this like trail, which we typically call a tail. And that's why it like has this like long streak in the sky, if you will. And the reason why this comet is so special, if you will, is because its gases are, I believe, mainly carbon. So once the heat reaches said comet while it's taking its path through its orbit around the sun, it's actually going to have like a cool like green tail.
Nice.
Exactly.
I hope it's a good green because I love the color green. It's one of my favorite colors. But there is such a thing as pea soup green, and I'm not a huge fan of pea soup green. I like more of a vibrant, bright green. But
I'd say this is like a more like a fun, glowy green.
Okay. Yeah.
Which the nice thing about any time that we've got different elements and how those molecules interact. In this case, it's like usually with sunlight. So UV light, the carbon molecules, and we get that consistent color. Some comets don't show that coloration much. Some show a ton of it. Our current comet is one of those, and it does allow us to like get an idea of, just by looking, we've talked about those colors already on the episode today, of how often color gives us an opportunity to make real observations and understand the composition of an object or what's there. And this is a prime example of that.
Exactly. Well, Kyree, before we move on to like the seeing stuff, what? I'm gonna use a fancy word here, but Kyree's answer will explain it. What is the orbital period of this comet?
That's a great question. I believe this is like a long period comet, and essentially the orbital period is how long it takes for an object to complete its orbit around another object. So it has a starting point, and then it'll travel around its path, whether it be circle or an oval, depends on ellipticity, but we'll leave that alone for now. And essentially, once it reaches back at that starting point, if you will, that's the amount of time that it's taken to complete that path is its orbital period. And like I was saying before, this is a long period comet, and it should be orbiting every 50 years. I mean, what?
Wait, yeah, that's still long. That's still long. That's still long.
But we want it really long.
We want it long, and then multiply it by 10 to the 3. That's what we're trying to say.
Oh, okay, so 50,000 years.
50,000 years.
Yes, and I'm going to say that again for our viewers, just in case that was a bit of a shock. 50,000 years. That means it won't be back for another 50,000 years.
Well, it's funny we should say that.
Ooh.
It's been 50,000 years since we think the last visit to the inner solar system. But looking at the orbital trajectory right now, kind of as it's moving through and all the different gravities things, there's a possibility that as it heads away from the sun and back out towards the outer solar system, that it may leave the solar system altogether.
Wow, that's new.
So we don't know yet, but
yeah,
it looks like there's a real chance this is going to get ejected from the solar system entirely. We're talking thousands upon thousands upon thousands of years, but eventually leave the sun's gravity for good. So thank you, Comet.
Yeah.
2022 C3.
Some of our viewers are probably like, why the heck is she smiling so big? It's leaving. Isn't that sad? Not like it's cool. It's very cool. Like that's something new. I've known about Comet since as long as I could talk, and it was always, they'll come back eventually. It's just a long time.
We're talking about escape velocity like not too long ago back in our previous class, with escape velocity being reaching such a high velocity that you can escape from your orbit. So it's really cool to actually have a physical representation of that, if you will.
That's cool. That's really awesome.
It's been very, very cloudy here in southeastern Pennsylvania where I am. Haven't seen it yet, but it is definitely a binocular comet. So unless you can get out someplace super dark, it's not going to be very easy to see with the unaided eye.
Yeah.
Exactly. And I would like to preface, I've never used a pair of binoculars before. However, I know people who have, and telescopes are also very difficult to use. But binoculars are now you're relying on yourself and your hands and your shakiness, if you have any, where the telescope has a tripod 3 prongs to sit on, and some of the fancier ones will move and have motors and things, but those are fancy ones. But it can be difficult, so do not feel bad if you can't catch it.
Exactly.
It's okay. And it's not like, sometimes in the movies people put these comets in the sky and they're huge and they're bright blue and they're just this awesome, majestic thing that takes up the entire sky. I have yet to see anything astronomical like that happen in our sky. I'm not saying that it can't, but in this case, it's not going to be this massive thing that is really easy to see like the moon. So definitely go outside, try and catch it, definitely get it. Tonight and tomorrow are definitely the best days to do it. And you'd be surprised, you'd shock yourself. And I really recommend giving it a shot. But don't let that discourage you. This is a hard object to catch, especially with binoculars. So don't let that discourage you from continuing to look at the night sky for other objects. Because there are objects that will stay still for you and are pretty easy to catch with binoculars and a telescope a lot better. But definitely give it a shot. Really briefly, so the path, for our viewers who are confused by me trying to explain it this way, if you go to skymaps.com, all one word, you can get a free sky map for February, and it'll show you the path that the comet is taking for you to see it with a sky map. And of course, if you want to come to the planetarium and talk to one of the planetarium assistants on how to use it, we will gladly help you with that. But that's a great way to look if you're confused by what I'm trying to draw. Because now it's kind of going to be around this general area, because the Big Dipper is right here. And if you continue drawing, this is supposed to be the face of the bear. And if you look on skymaps.com and look for the path of the comet, and it'll tell you date-wise as well where it'll be, it's around this general line area. So again, Mars creeping back down to about here in this open space-ish. I hope that helped. Otherwise, feel free to check out skymaps.com. Check out our Facebook page. We'll definitely be posting some stuff about it. Also, I would like to tell our viewers, if you've never used binoculars or a telescope before, what you think is a tiny little bump is 5 miles that way in a telescope or binoculars. So it takes some adjusting and getting used to, but that was something that always frustrated me when I was younger and first learning how to use telescopes. And I say younger when my first telescope was here in college, believe it or not, but it was a very frustrating thing for me to deal with. So I am passing on the knowledge.
Totally fine. My first telescope was freshman year. Built it. Got it from a thrift store. Thrift stores are your best friends, people.
Well, I believe that is the end of our comets and constellation parts of our program. So, Michael, any comments or critiques?
No critiques, other than myself. No, this is a wonderful time of year. There's just so many bright stars, and we saw Orion is such a good sort of, Orion, you can find probably 10 other constellations and bright stars and Mars and everything else. And it's just like, get that's your signpost, points you in all the right directions. It's for those of you who maybe haven't been under the sky too much, and you walk outside and it's just stars everywhere. It doesn't seem to make any sense. There's a point, and especially with Orion, you point it and you get to a bunch of other constellation stars, and the whole sky just makes sense in an instant. And it's a wonderful feeling. So as long as we don't freeze, it's good to get out there, give Orion some time, and check out the really cool stuff that's in the winter sky.
Awesome.
Wear up, people's coat.
Yes, and it is going to be cold tonight here in Muncie, a low of 19 degrees or something crazy. So please bundle up and be safe, and always be vigilant of your surroundings. And as a reminder, this night sky is just after sunset in Muncie, so around 7 o'clock-ish, give or take a half hour. So of course, Ursa Major will definitely be climbing a little bit more in the sky later in the evening. So just do your best and definitely give it a try. I guarantee you I'm not going to see this comet. Because I am horrible with telescopes and binoculars, even though I have yet to hold an actual pair of real binoculars and not child ones that are this big.
And
But
for fun, leave in the comments if you find it or not.
yes, please let me know if you see it. Please comment on our YouTube video of this Constellation Crew episode. Please comment on our Facebook page or Instagram page. We will definitely be putting our social media up at the end of this video. Please show us what your setup, what you've seen. It's really fun to see all the different ways that people love to observe and where they go to observe the night sky. It's a lot of fun. But since we are reaching basically the end of the episode, we have our mini Q&A, and I'm very excited.
Lightning round.
Lightning fast. So my questions are pretty easy, and we're going to save one that is inspired by our planetarium director, Dana Thompson, at the very end, because I think it's very sweet and inspirational.
I'm excited.
And I'm kind of jealous that I didn't think of it, but it's okay. But my questions are apparently, and are pretty easy questions, I would say.
Okay. I'm ready. Prepared.
So,
here we go.
What is your favorite constellation and why? And I would like to specify that you don't have to pick the Northern Hemisphere if you do not want to.
It is. We're gonna go with a simple one. Favorite constellation is Orion. Reason being, it was the first constellation that I was able to recognize.
Aww.
And it doesn't matter if you're at a dark sky or you're in the middle of a city and you look up and you see those 7 brightest stars, and it takes you back every single time. So definitely going to be Orion.
Definitely agree, because I was in Seattle, Washington recently, and I was able to pick out Orion in the heart of Seattle, which I was shocked.
Fantastic job.
The next question is, what's your favorite astronomical object?
Favorite astronomical object. Again, it's a real like typical one, but it's Saturn.
Okay.
And specifically the Saturnian rings. There was one night in undergrad, we had set up a big 12-inch diameter telescope, and the steadiness of the sky was perfect. It may be the best conditions I'd ever been in, and saw Saturn through the scope. It was one of the first things I'd ever seen through a telescope. Anyway, you don't ever forget that. But it was these little divisions in the rings and bands on the planet, and at least 4 or 5 of the moons. It was like when people say, "Did you put a picture in the telescope?" Which is one of the great questions asked of every person who's ever had a telescope out. Is that a picture? It looked like a picture. And I can vividly remember like stepping back and, I've seen Saturn 100 times. And the 101st time, you're just floored. Like you've never seen it that way. That goes along with, it's my favorite astronomical object to show people, because you don't have to wonder whether or not they've seen it. Right. They're like, what do? I look through the telescope, and they put their eye to the eyepiece, and then there's a little bit of quiet, and then there's the whoa, and you're like, we're good. If you're 5, we're good. If you're 105, we got you. Yeah. Everybody has the same experience, and it is a rush. It is a rush that you take it every chance you get.
That whole reaction is exactly what happened when I took observational astronomy 2 semesters ago, and we were up on the rooftop observatory with Dr. Bob Barrington. He was our professor for the course, and again, never looked through a professional telescope before. I had the rinky-dink lens one that you got at Toys R Us, which is still great. It's a great starter telescope. Love it. But I never got to see any of the planets. So he's like, hey, Nicolette, take a look. There's your favorite planets in here. And everyone who knows, who is a young person and has adults around them all the time, knows that you have a certain persona when you speak to an adult. You have a certain amount of respect. Sometimes you even have a certain way of speaking. And in that moment, I was in such awe, and I thought I was going to cry because I've never seen Saturn like that before in my life, that I was just all over the walls, and I was freaking out and said some selective words because I was so amazed and shocked, and I'm like, I can't believe
that is the only appropriate reaction.
Exactly.
And Bob's like, you've never seen Saturn through a telescope before? Like, he's just shocked. He's also never seen this side of me either, because I was trying. So he was like, what's happening? And I'm like, yes, I've never seen this before, and you brought this wonderful joy to me. So
It is
I
a
relate.
deeply overwhelming experience.
Yes.
Really
Very
is.
My final question would be, what would you say to younger you, or to our younger viewers who love astronomy and are watching today, about getting into the astronomy field?
That's a fantastic question. The top one, and it goes for everything, but even here in astronomy, is never stop asking questions. Astronomy is really one of the most fluid and dynamic fields in science, and what we know today could be obsolete tomorrow. And that's not scary, that's wonderful. And being able to embrace the unknown and to strive to understand it the best we can. We'll never fully understand it, but it's that sense of never stop asking questions, never ever let yourself get in your own way, and love it. Like, it's okay to be amazed by this. So keep that sense of joy that comes from seeing things that you look at a galaxy and you're looking at light that left stars in that galaxy 100 million years ago. It's mind-boggling. And keeping that open mind, that's how you do it.
Mm-hmm.
Never stop learning.
That was awesome.
That's great. That's great.
Thank you. That's perfect for our younger viewers if they are watching us today. But I believe Kyree has some questions for you as well.
Yep, I have two. One of them sort of similar to the last question we just asked you, and one of them we like kind of brushed over in the beginning, but I want to get the full story. The first one being, I already forgot it. That's crazy. What do you wish you knew before you stepped into the field of astronomy?
Well, for me, it was stepping into, I think, the planetarium world before officially stepping into the astronomy. And like, I'm an amateur astronomer. I don't purport to be a professional astronomer. There are many, many smarter people than me in this field, and that's a great thing. That helps me to strive to be better and learn more and understand things better. But the one thing I wish I knew was that there are so many more people like me than I ever thought there would be. It's like, oh yeah, it's the little astronomy nerd who grew up to be a larger astronomy nerd, and then meet people who are so happy and engaged and thrilled to be doing this and to learn and to discover and all of that. That, like, knowing that beforehand would have made it all the more fun getting into it. This is probably more of like, it's the one thing that I had no idea that I learned right away. We are a fun bunch of people in the planetarium world, and there are a lot of really, really fun and just deeply caring people in the field, astronomy and planetarium otherwise. And that all together makes what we do just so much more enjoyable.
I agree. 100%.
I totally agree with the fact that there's just a lot of caring people within the planetarium world. I've met a bunch throughout my two internships with Adler, with my time here, and Brown. So yeah, I agree.
Very cool.
And you did like brush over in the beginning, but now I'm What was your first experience? What was your experience with getting your first ever telescope, if you got one? I know you mentioned you got one.
All right, so I can be very specific with that story. It was Christmas 1992. I was 7. My family had just moved to Florida earlier that year, and I, at that point, had gotten. So there was this time, of course, before. Don't want to sound too much like an old man, but where like the majority of information one could get about the stars and space came from your local library. And for months and months, I had like, I think the limit was like 7 books for a kid's library card. And I had taken 7 books about astronomy and space and planets out every single time I could get the chance. So it was just getting so into it, and the pictures and the numbers and the ideas, and it was so amazing. Wake up on Christmas and there is a Tasco refractor. It was a 60 millimeter. It is like the quintessential late 80s, early 90s first telescope. And looking back, it was a piece of junk, as many department store telescopes were back in the 80s and 90s. But yet, that piece of junk, better optics than anything Galileo had access to, was about as good a telescope as Charles Messier had. And when we went outside and you see the moon, and there are craters inside of craters inside of craters, and then the shadow of the Terminator is like stretching the shadows across the lunar surface, or to see Saturn's rings or the moons of Jupiter, or even like the tiniest hint of like the ice cap on Mars, or the small like wisps of the Orion Nebula. It immediately. I now have 3 telescopes at home, which is probably 2 more telescopes than I need right now, but they're there, and I can go out on my patio and been able to share that experience with my son, who's 8. And he's seen the moon and Jupiter and Saturn's rings and had the same experience that I had. And to be able to see that and have that connection, incredibly. It's like great as a dad, great as a planetarian, great as a human being. But being able to have all of that traced back to like, and it was Christmas in Florida, which meant it was about 70 degrees when you went outside that night and not freezing. And there's something about being able to stand outside with a telescope in your shorts and take a look at the sky in the middle of December. Been hooked ever since.
Wow. That's so beautiful. That's wow.
great.
I could cry. I really could. But I am the waterworks of my family, so it's okay.
Would that be a first on Constellation Crew?
Probably. Yeah.
Okay, we'll have to save that for a future.
We'll have to say that.
Find someone. We'll find someone who cries more.
All right. This is our last question, and then we will do a brief outro. But once again, inspired by Dana Thompson, how do you stay motivated in your field?
This sounds like a Dana question.
He's a
1,000,000%.
I think 1,000,000 is an understatement.
It is the prototypical Dana Thompson question, and it is one that, and I mean this in all seriousness. It's something that I've known Dana for years. She's an incredibly close friend, and this has been asked of me before. But it changes. The answer changes, as it should, as one progresses through their career and all that. For me, the motivation in the planetarium world is the whole of the community. What motivates me is seeing generations of planetarians younger than me. Not that I'm old by any stretch.
You're
but
not.
There are several generations of planetarians who are coming, and Kyree and Nicolette, you two represent that, of these incredibly bright, motivated, open-minded people coming into the field, who I, especially in my role as president, that I can take things like my privilege and what I have and my opportunities, and I can remove obstacles for people and then get out of their way and watch people do greater things than I could ever have imagined. And that motivates me every day to do the best that I can for the planetarium community. If I'm in a dome and I was giving a show and there's kindergartners and given thousands of those shows in my career and loved every single one of them. But I don't know, if I present a planetarium show today and somebody in that audience gets inspired to change the world, I don't know if the next Sagan or the next Einstein is sitting in a talk or a presentation. it motivates me that maybe I have a hand in inspiring them to do the great things that they want to do and to empower voices and ideas and perspectives. And that's really exciting. It's like there's a bright future that I get a little part to play in that, but what's to come and what people will do beyond me motivates me to do my best, because that's going to allow others to do their best, and so on and so on. And we're going to continue to grow. We're going to continue to get new people and new faces and new ideas. And the future motivates me, the past inspires me, and the present drives me every single day.
Wow.
So I hope that, in 10 or 20 or 30 years, that like Kyree and Nicolette, it is people exactly like you who are leading and inspiring and empowering, because you felt led and inspired and empowered. And that's all we can do to make the future better for the planetarium world, for the astronomy world. And for me, it is what keeps me motivated every day.
So close, man. I feel it. It's in the corner of my eye right here. It's gonna fall. It wants to. But gravity's not strong enough.
Shut it down. Put it to the highest corner of your brain.
We can't push her over the edge on this. Like, we're good.
No sobbing on Constellation Crew. Well,
there's a tear in the corner of your eye. Block it out.
Suck it back in. Anyway, sorry for that sound effect, but I know that many of my viewers are probably like, what the heck was that? Sorry, it's a habit. Anyway, thank you so much, Michael, for dealing with our questions. They were very beautiful answers.
It was my pleasure.
I know for a fact that I know you touched me, and I'm pretty sure you touched Kyree, but I'm pretty sure you also touched someone in the audience today, and that is a beautiful thing. Sadly, though, we do have to go. This is probably one of the longest episodes we've had, but having a guest like Michael makes it very hard for it to be very short, sweet, and to the point, because we just love talking about space. But don't forget, we are Constellation Crew, a part of the Charles W. Brown Planetarium, and we do have some shows. If you haven't been to one of our shows, you absolutely should. And this coming Friday, February 3rd, we are showing Dynamic Earth. I don't remember which one that is, because there's a lot of shows with Earth in it. But I guarantee you it's a fabulous program, because every program I've seen here always inspires me, amazes me, and has amazing visuals. So highly recommend. And of course, we will also have Saturday showings in the morning for our kids program. You don't have to be a kid to come, because it is One World, One Sky with our buddy Big Bird. And Kyree loves Big Bird. So
please come.
Absolutely should come if you love Sesame Street. And then we will have another showing called Eclipse, The Sun Revealed. Really great program. And of course, Dynamic Earth again in the evening. So feel free to come Friday, February 3rd, or Saturday, February 4th, to come see some of our programs. And of course, we do change our shows. So these will be playing for a little while, so don't panic. These aren't the last days or anything. But feel free to check out our website, our social media. We definitely update our shows there. And of course, we would love to hear from you guys and see pictures of your Comet, see pictures of your setups. Please interact with our social media. We love being a part of the community. That's our job. So feel free to comment and follow any of our social medias. Any final comments, my crew members?
Just keep trying. That's all I can say.
Just keep trying. All right. Well, thank you all for watching our show today, and I hope you all get a chance to see the comet, and I hope you discovered something new in the sky for us. Bye, guys.